Okay, so I just have the formula sheet pulled up, and remember, this will be provided for you on the test. I just, real quickly, we're still in 8.5. I had you guys copy all these formulas down right here, but we hadn't really done anything with them. I gave you these as well. Since they are given to you on the sheet, don't worry about memorizing those. You will have one set today that you've got to know. They come up more often. So just make sure you're comfortable using these. But I want to show you the point of these today. And remember, I had kind of hinted around a little bit why we would go to these formulas in the first place. And that is if you have something like pi 12ths or an unknown angle. It's not a 30, 60, or a 45, or even a quadrantal. And so if it's not, sometimes you can get the exact answer by breaking it down into either a sum or a difference on the angle. And so I want to show you how to do that. Okay, so what we'll do, let me just start showing you a bunch of examples. We're going to start out, of course, I don't think you guys will be at all surprised. Guess what? I like to work in radians. Okay, that's me. You guys may want to convert to degrees. Remember, you can always convert over. I'll show you 1 degree problem, but everything else I'm going to do is going to be in radians because that's my preference. So I'm actually going to start out, I think we'll do cosine. We're going to look at question 19 that says find the exact value, which means you can't approximate it, of the expression. And if we look at number 19, we have the cosine of 7 pi over 12. All right, it's already set up in radians, which is my preference. You guys can see that you can't reduce it. It's in that 8 pi over b, but it's not a denominator 3, 4, 6, or 2, or just a pi. And those are things we know how to work with. This is not something we know how to normally get an exact value for. I'm going to show you 2 different ways to handle this. A lot of times you can do them several different ways, and I want you to be aware of that. So just show your work on the test. You may see it right away, by the way, but you might not. So if you're kind of stuck and you're trying to figure out how to break it down, remember your goal is to get a denominator 3, 4, or 6, or get a quadrantal. So that's a pi over 2 or a pi, something like that. Those are what you're looking for. I'm going to do an addition on this case, and I'll do a subtraction on the next case, and that way you've seen both, because you can probably interchange them here. So what I like to do is I'll look at 7 pi over 12, and we're going to break it down. And I'm going to do addition here, but I think you could do subtraction just as easily. So when I start to kind of break this down, you want to make 7 pi 12ths. And I'm actually just going to break it all the way, even though some of them I know don't work, just to kind of give you a method to use. So if you're trying to get 7 pi over 12 with addition, the most obvious would be 6 pi over 12 and what? Pi over 12. Because you guys see those summed together to give you what? 7 pi over 12. Now, on the left, it actually works out well because the 6 would reduce the 12 down to a 2, which we know how to work with. But on the right, you still have a problem because you have a denominator 12. Do you guys see it? So that's out. That's not going to work. They both have to reduce to that denominator 3, 4, 6, right, or to the quadrantals. So keep going. This would become 5 pi over 12, and this would become what? 2 pi. Do you guys kind of see the game I'm playing here? And that doesn't work. The 2 pi over 12 would work because 2 would reduce the 12 down to 6, but the problem is the 5 doesn't reduce the 12. Does everybody see it? So we're going to keep going. The next one would be 4, and what would this one be? 3. Does everybody see that? And does that work? Yes, it does. And you may have seen that right off, and so if you see it right off on the test, by all means, just go straight to it. I'm just giving you something just in case you don't see it right away, okay? So this is going to work for you. So we're going to rewrite this. Instead of doing cosine of 7 pi over 12, which we can't get an exact for, we're going to rewrite it as the cosine. The order, by the way, does not matter. You can put it in either order. You'll still get the same answer. I'm just going to go the order I have, 4 pi over 12 plus 3 pi over 12. And you guys can see that is the exact same thing. Does everybody see it? What makes this so handy is that 4 will turn 12 into what? 3, bingo, because that's the denominator we know. And 3 will turn 12 into what? 4. And so now you're working with something that you can get exacts for. So this is really the same thing as cosine of pi over 3 plus what? Pi over 4. Do you guys see that? And we know how to get an exact for pi thirds, and we know how to get an exact for pi fourths. Make sense? Okay, so we're going to move this over. And what I'm going to do now, you guys will have your formula sheet. And in essence, what you're looking at, the formula is cosine of what? Alpha plus beta. And remember, cosine, if you didn't have the formula sheet, although you do, I always remember it's the cosines, then the sines, and the sign is opposite. So it'll be cosine alpha, cosine beta, change the sign to a minus, and then do sine of each of them. So it'll be some version of that. Are you guys okay there? And that's given to you, so feel free to not worry too much about that. In our case, this is alpha, and this is beta. Do you guys see it? And I'm going to go ahead and get the information I need. In this case, the reference angle is 60. Pi thirds is in quadrant 1. You guys all right with that? What's the reference angle here, guys? 45, and this is also in quadrant 1. Everybody okay? Now, you either need to know your points on the unit circle. Remember, we talked about knowing quadrant 1 and then just changing your signs, or know your 2 triangles, however you're comfortable. The truth is, I don't care. Just use whatever you're comfortable with. I'll go ahead and put the 2 triangles down. This really should start becoming kind of second nature to you guys now. It almost has to, right? Because you just use this stuff all the time. So either that or just know them on your quadrant 1 points and you should be able to get it. So for us, we're going to have cosine of pi over 3 plus pi over 4. We're going to substitute in for alpha the pi over 3. So cosine pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. See if you see that okay. And so now, knowing that it's in quadrant 1, we know all of our trig functions are positive in 1, so we don't have to worry about the sign. Looking at a 60-degree reference angle for cosine, you're looking at this part. 60 degrees would be what? 1/2, or if you know your points on the unit circle, that's you'll generate it right away. 45 would be what? Root 2 over 2. Good. 60 degrees for sine is going to be what? Square root of 3 over 2. And this one's going to be what? Root 2 over 2. How are you guys doing? Everybody's good? Okay, so for our final answer, multiply your tops. You get square root of 2 over 4 minus, remember these are both a second root, so you can multiply the insides. You get square root of 6 over what? 4. And if you'd like, you can, since they have the same denominator, you could write it like this. And that's your exact. And that's what they're looking for. Just taking the 3 times the 2. Since they're both square roots, you just multiply the inside. Correct. You got it? Yeah. I don't think that's that bad. If you know the other, I mean, compared to the inverses, this is a piece of cake. So hopefully you guys will feel that way about most of the material. I think the inverse stuff is really rough, and I like this stuff because it's not as bad. So it balances a little bit. All right, you guys feel pretty good with that? Everybody's got it? All right, I want to show you a sine. I want to show you a tangent so that you can kind of see a nice variety. The next one we'll do a subtraction, and then you can just kind of pick what you want to do on the test. I don't dictate. I'll let you kind of choose. All right, so the next one, again, they're asking us to find the exact value of the expression. So I'm going to come over here, and we're going to take a look at a sine. I've got the sine of 17 pi over 12. And I'm choosing to do a subtraction. I think you guys could easily find an answer doing an addition, breaking it down like I showed you, but I just want to show you how to do both cases. So this time we'll take this 17 pi over 12. We're We're going to split it up, but we're going to do a subtraction. Now, it's a little bit different on the setup to subtract. You're going to have to take and do something more like this. Take this side kind of up, and this side what? Would just be, do you guys see the subtraction would be 17? Does that sort of make sense? Okay. Oh, should be 12, sorry. Yeah, sorry about that. I think I said it and just never got it on paper, so, yeah. All right, is everybody okay with that? So we could break down a little bit more. You would have to take this up to what? 19, and this what? To 2. See how I'm playing that game still? Because 19 minus 2 would give you what? 17. Problem is 19's prime, so you're still stuck with that 12. On the top, of course, the pi 12s didn't work. But it still is a way to kind of get you going. Can you guys tell me what the next 2 would be? Good, 20. And then what? 3. You guys see how to play the game, right? And actually that one works, doesn't it? Does everybody see? Because the 20 and the 12 both would reduce by 4. And you'd get that denominator 3 down there. And then the 3 would reduce the 12. So that's one. Now, if you keep going, you could probably find some other ones. So if you just see something else, I'm fine with that. I don't care. But this is a way if you get stuck. So those are the 2 I'm going to use. So we're going to do sine of 17 pi over 12. We're going to rewrite that. Let me clean that 17 up a little. As the sine of 20 pi over 12 minus 3 pi over 12. And so here we know 4 will go 5 times there, and 3 times there, and 3 will go 4 times there. Do you guys see it? And so the simplified form would be the sine of 5 pi over 3 minus pi over 4. See if that looks okay to you guys. Okay. Okay, I'm going to move it over. I'm going to grab my formula real quickly. I know with sine, it kind of mixes the sines and cosines, and the sine stays the same in the middle, but you will have the formula given to you. So sine of alpha minus beta would be sine of alpha cosine of beta minus, and I just always keep the sign here, sine of, well, I don't think they do it this way in the formula. That's okay. I'll switch it. I'll do then cosine of alpha and then sine of beta. You want to make sure each trig function gets hit with the angle. And the order really on the sines or cosines doesn't really matter there. So just use what's on your sheet. So notice I hit sine with alpha, I hit cosine with alpha. Does everybody see it? I hit cosine with beta, it's sine with beta by the time it was all said and done. But like I said, those formulas are given to you, so don't sweat it. This is your alpha, this is your beta. The minus is worked into the formula. I do want to tell you guys, if you want to change it to plus a negative, you can use your sum formula. All right, and that's perfectly fine. I just never do. I just always either use the subtraction or use the addition, but you absolutely can do it that way. Okay. If I don't have to work with a negative angle, I usually don't pick 2. So I'll just leave the negative in the formula. So beta is just the pi force, okay, unless you change it to a plus negative. And then you use the sum formula. All right, so a couple things I want you guys to see. Let's take a quick look at 5 pi over thirds. I'm going to just open up my simple calculator here and plug in 5 thirds. I just want to get an idea on the quadrant. So if I take 5 divided by 3, I get about 1.67 pi. And so I'm only doing this just to review because I know you guys are pretty comfortable. I know I'm moving what? Clockwise. So this is 0. This is what? 0.5. This is pi. This is what? 1.5. And this is what? 2 pi. Does everybody see that it's 4? Everybody good with that? So this is going to be quadrant 4. What's the reference angle here? Good. What quadrant is pi force in? Reference angle is 45. And again, you can either use your points on the unit circle, I'll just go grab my old ones, or you can use your 2 triangles here, which is what I'm grabbing. And the truth is, I just want you to use whichever you're the most comfortable with. So, however you're comfortable. Okay, so let's see. We're going to have sine of, we're going to have 5 pi over 3 minus pi over 4. So we've got sine of 5 pi over 3 times the cosine of pi over 4 minus the cosine of 5 pi over 3 times the sine of pi over 4. Everybody okay with that? So just plugging in my alpha, of course, plugging in my beta. All right, so 60-degree reference angle for sine would be what? Square root of 3 over 2. It's going to be negative. Why is that, guys? Quadrant 4. Good. You're all students. All students take calculus. All right, this is going to be what? Root 2 over 2, it's in quadrant 1, so it'll be positive. Minus, what's this going to be? 1/2. And cosine in 4 is actually what? Positive, so you'll leave that, and this is going to be what? Root 2 over 2. And so I'm getting negative square root of 6 minus square root of 2 all over 4. See if that looks good. And if you had used a different pair up on your angles, you'd still get the same answer. So everything should come out, you know, the same. Okay, we're going to take a look. We're going to do tangent next, and I'm going to go ahead and leave it in degrees, even though my preference would probably be to change it over to radians and work with radians. I just want to show you guys you can work with degrees if you would like, so just to get an example out there. But anytime if you're like, I much prefer radians or I much prefer degrees, just convert. That's why you have those conversions, so that you can work with whichever you'd like. Again, it's going to be find the exact value of the expression. So we're going to come over here, and this is question number 15. We've got the tangent of 15 degrees. And again, if you wanted to convert it, you could take that 15 degrees and multiply it by what? Pi over 180. And then you could get in radians and do just like we did before. I actually see this one really, really easily because it's, I don't know why, probably just because I've done it a bazillion times, but I see it's 45 minus 30. Does everybody kind of see that? If you're not seeing it, though, if you ever get on the test and you're like, I'm stuck, convert it to what? Radians, and then use that system that we use, because that's always going to work. You're going to find it that way. So, but if you see it right off, I mean, that's great. So I'm going to actually use tangent of 45 minus 30 degrees. All right, are you guys okay with that? So you can stay that way if you'd like. Now, again, you're going to go to your formula sheet for this one. We know this is alpha and this is beta, so we're doing tangent of alpha minus beta. I know it's tangent of alpha minus tangent of beta, and then it's 1 plus tangent alpha tangent beta. But you should have that sheet. You should have that on your formula sheet, okay? Couple of things that I see real quickly. I already know that's 45. That's in what? Quadrant 1, and this is also in what? Quadrant 1. So this is a little easier in that those are in quadrant 1. The reference angle is the 45 and the 30. I'll real quickly just switching screens, going to grab my 2 triangles. And I'll move that over into the corner here. Or just use your points on the unit circle. So we're saying tangent of 45 minus 30 would be tangent of 45 degrees minus tangent of 30 degrees over 1 plus the tangent of 45 times the tangent of 30. Everybody doing okay? So we're going to have, let's see, tangent of 45. Again, you're using the TOA here. It would be, does everybody see it's 1? Right? Or use your points on the unit circle. That's fine. You do root 2 over 2 over root 2 over 2 because tangent is what? Sine over cosine. However you have it, I don't care. Or from your triangles, just do the opposite over what? The adjacent. Make sense? What about the 30 degrees? What do you guys see for a 30-degree reference angle for tangent? 1 over what? Root 3? Or do you guys want to write it as just root 3 over 3? If you want to go ahead and rationalize it, that's fine. And then here we'd have 1 plus, we already know this is 1, and this is root 3 over 3. All right, I'm going to start moving it over here. Let me just grab it. And then this is what we have so far. Okay. All right, so we have 1 minus root 3 over 3, and then over we have 1 plus root 3 over 3. And of course, it's a complex fraction, so you want to get rid of the 3 that's causing all the havoc for you to have a fraction in the numerator and a fraction in the denominator. Remember, though, it goes to all terms, so be a little bit careful when you technically multiply the top and bottom by 3. Remember, it does what? It distributes to both terms. So I usually don't write it like that. I usually just go straight to this step where I do what? Times 3, times 3, times 3, times 3. I'll go ahead and distribute it through. Does that make sense to you guys? So then the 3's cancel here. And you're left with 3 minus root 3 over 3 plus root 3. See if that looks okay if you're with me so far. Now, I want to say this. On the test, you are perfectly fine to stop here, because if you keep going, you're more likely to make a mistake. And let's face it, you don't, on the test you have time constraints, and you just don't always do as well as you do when you're not so nerved up about a test, or I never did. But I think MathLab is going to make you take it all the way. So I'm going to show you this, but I just want to let you know that on the test, you are fine to leave it right there, okay? What MathLab is going to do is, you probably remember this from, I'm thinking this is maybe pre-calc that this comes up. They don't like you to leave the square root of 3 in the denominator. So to rationalize it, because you have 2 terms down in the denominator, use conjugate. Is it sort of coming back? All right, so we're going to do this, but let me stress this. Do not do this on the test because it's so unnecessary. And this is going to take you an extra 5 minutes to do this. Okay, I'm going to move this down here. Now, if I'm wrong and MathLab is no longer making you do this, please let me know, because I won't do it anymore in class. But I do believe it is. I think it does make you do it. Okay, so conjugate on the denominator, because that's where you want to get rid of it. You change the middle sign. But if you do it to the bottom, guess what? You got to do the exact same thing to the top. So what I'm going to do on the top is I'm going to FOIL, and what I'm going to do on the bottom is I'm going to use the formula. Okay, you can FOIL it too. If you FOIL it, you'll get there. It'll take you a few extra steps. So in the top, FOILing this out, I would have 3 times 3 would be what? 9. And 3 times negative square root of 3 would be negative square root of 3, and then minus 3 square root of 3, and then square root of 3, negative square root of 3 times negative square root of 3 becomes what? Plus 3. Make sense? So that's from FOILing. In the bottom, remember, what is this? A squared minus B squared. So I'm going to have in the denominator A squared minus B squared. And so it's the squares that take care of the radicals down there. That's why the conjugate kind of works. And And so these two right here that I just boxed in, those are like, so I can combine those. It's just like taking negative 3x minus 3x becomes what? Negative 6x. Same thing, they're both square roots of 3. So minus 3 becomes minus 6 square root of 3 plus 3. And then down here you've got 9 minus 3. See if that looks okay. Are you guys good there? And so I'm going to combine the 3 and the 9. So that's 12 minus 6 square root of 3. And then in the denominator, I have, what, 6? See how it got rid of the radical down there, which is what they wanted. All right, I'm going to move this over. And the last thing I'm going to do to finish up is just take out what's like. So this is what I have. And so in the numerator, I've got tangent of 45 minus 30. In the top, do you guys see I have a common 6? And that will leave me with 2 minus what? Square root of 3 if I factor that out. And then what can you do? Cancel the 6's. Make sense? And so you get this 2 minus square root of 3 as your most simplistic form. I'm not going to argue with you that that looks a little cleaner than our initial answer, but does it really matter? Not really. So, you know, with calculators these days, you can plug it in and get the approximation anyhow really easily. So I wouldn't worry too much about it. Okay. Okay, I have 3 more things to show you from this section. So I'm going to actually stop and restart here.